Now, how does blockchain work? Here's a step-by-step view of how a blockchain transaction might work. So first, if you are a participant in a blockchain platform, for example, and you want to request for a transaction, so that transaction would be created, put into a block that would represent that transaction. And then that block would be broadcasted to all the other nodes or participants in that network. When that gets broadcasted and it gets to all the other participants, these participants need to validate that the block and the transaction are okay and valid. And there are certain models and algorithms that are used in order to validate this transaction. We're going to talk about it a bit later. And once that is validated, the block is added to that chain, and the transaction gets verified and executed. Now, if you look at this entire process, there are basically three kind of components or steps or functions in this entire process. The first one is initiation and broadcasting of the transaction. And in order to do that, there are certain components that are required. And these are private and public keys and the digital signatures. We're going to talk about them in a bit. The second part of the whole process is validation of the transaction. Now, as I said, there are different ways of how transactions can be validated, different consensus mechanisms that are employed across different blockchain platforms, but the two most popular ones are proof of work and proof of stake. There are many others, but they're not as popular as these two. And the final component in this entire process is chaining the block. So in order to do that, hash function is needed, and we're going to explain in a little bit how that works. I know this is a little bit technical. You don't have to worry about this. To be honest, there are so many technical things about the internet and mobile applications that we use, which we do not understand, but yet we know how to use these applications and the internet. So the same thing can be applied here when it comes to blockchain. We don't really have to understand the underlying technology that is used and all these concepts and how it works in order for us to use it successfully. But it is for the sake of this class, because we are students, we seek knowledge. So I'm just going to briefly go through it for you to have an idea how it works. So what are private and public keys? This is something that is kind of similar to, for example, our bank account and the password that we have for it. So private key here would be the equivalent of the password that we have. And public key would be the equivalent of the bank account number. Now, you don't want anyone to know your password, but you are okay with people knowing your bank account. In fact, if you want anyone to transfer money to your bank account, you need to reveal that bank account number to them. So the same concept is kind of applied here, but at a much stricter level where security is at a much higher level than the password technology that is used. Now, private and public keys are created with the initiation of the first ever transaction. It's basically a long string of alphanumeric characters. That's nothing really pleasing for eyes, but that's what makes it very secure and safe. And the public key is generated from the private key. Now, this is a very important feature. So the public key is generated from the private key, and the process cannot be reversed. Now, when you go, for example, to open a bank account, you get your bank account number first, and only after that you get your password, correct or not? And very often, the first password that the bank gives you is the password that they want you to change and choose your own. But here, funnily enough, it's the private key that gets generated first, and from that private key, the public key is generated. And what is good about it, that you cannot reverse the process. In other words, it's impossible that people who have your public key can now reverse the process and get your private key. And this is very crucial, because if they could do that, then of course they could also access whatever is under your account. Digital signatures are a digital code that are generated and authenticated by public key encryption, which is attached to an electronically transmitted document to verify its contents and the sender's identity. So this is another level of security that is added to the whole process when transacting between nodes. When a transaction is initiated by a user to send, let's say, Bitcoins to another person, the transaction has to be broadcasted to the network, as I explained earlier, where the distributed participants or nodes confirm the validity of transaction before finalizing it and recording it on the blockchain. Now, before the transaction is broadcasted, it has to be digitally signed using the private key. This digital signature proves ownership of the private key, although it does not divulge the details of the private key to anyone. Since the public key is fashioned from the private key, the user's public key is used to prove that the digital signature came from his private key. And once the transaction has been verified as valid, the funds are sent to the recipient's public address. Now, the whole process of validating these transactions is a very complex thing to understand. They're basically mathematical algorithms, and we're not going to go into the details of these, but just to give you an idea between the differences of different concepts, we're going to go through the two most popular ones. So, validation of transaction, or these consensus mechanisms, are used to confirm transactions and to add new blocks to the chain. Now, to do this, miners or the nodes that are in the network, they need to solve certain mathematical problems. Now, in the case of proof of work, that's one of the consensus mechanisms. The amount of work done by a particular miner determines his or her possibility of mining a block and getting their reward. Now, for the sake of simplifying things, if you might be wondering what a miner is, let's say it's just at this point, miner is a node in the network that works on validating the transactions. What's specific to this proof of work is that it's a very democratic and very fair system where everyone has an equal chance of mining that block, meaning validating that transaction and adding the new block to the chain. And once that happens, and whoever does that, they get the reward. And for example, in the case of Bitcoin, they get a reward in the form of Bitcoin. Now, when it comes to proof of stake, proof of stake states that a person can mine or validate block transactions according to how many coins he or she holds. And just to add to proof of work, it's kind of random who gets to mine, who gets to solve this mathematical problem and thus mine that block. In the case of proof of stake, it's kind of different because it depends on the stake that you have in the entire currency, cryptocurrency, for example. So if you have, for example, 10% of the total cryptocurrency value, then you get to validate 10% of all the transactions. That's what proof of stake means. Now, in the case of proof of stake, it's slightly different that transactions are validated and how the nodes who validate it get rewarded is by actually charging certain fees. And there are many other valid consensus mechanisms, some of which are delegated proof of stake. It's pretty much similar to proof of stake, except that here nodes who would be validating the transactions are delegated. It's not based on the stake per se, but the nodes would delegate that right to them. What constitutes a blockchain? Now, if you remember, the third component that we were talking about, that whole process, is chaining the block. Now, the whole process looks something like this. So if you're talking about a blockchain platform that you're launching for the very first time, then that first block that would be generated is called Genesis block. So for example, whatever transaction you might enact in that blockchain platform, it would be stored in that block, and it would be cryptographically sealed by using the hash function. Now, if a new block, if there are new transactions which need to be added to that block, and once they're validated, they have to be chained to the previous block. That's where the word blockchain originates from. So what needs to be in that, in order to chain that block, what is needed is the hash from the previous block, right? So that is something that is shown here. So you see that that hash has to be the same. And then the data that is in that second block, and then that hash would be created in order to cryptographically seal this block and chain it to the previous one. And then every subsequent block would work in the same way. So each block has the following key components. There's data, there's a hash, and there's a previous hash. In the case of the Genesis block, there's no previous hash, so it's just zeros. But for example, in the case of block 2, previous hash is needed as well, and metadata, which includes the timestamp and block number. As I said earlier, one of the key characteristics of blockchain is that the data is time-stamped. Now, what is hash? Hash is basically a unique identifier for a block and is analogous to a fingerprint for a human. How is it calculated? Basically by using cryptographic algorithms employed in the blockchain. Now, I hope you understand where that whole word blockchain comes from, because you have blocks that are chained to each other. And now you may also easier understand why blockchain is immutable. So for example, if you wanted to change anything in block 2, right? Whereas block 3 has already been added to this chain, to this blockchain. First, you would have to unlock or break into this block 3 before you can break into the block 2. Now imagine, for example, in the case of Bitcoin, blocks are generated every 10 minutes. So if there was some transaction that you generated this morning, right? And then in the end of the day, you realize that, oh, that transaction was wrong, I want to change it. Imagine how many blocks in that chain you would have to break in order to get to that block in which your transaction is that you wanted to change. This is why we said earlier that one of the key characteristics of blockchain technology is immutability. Theoretically speaking, it's still possible to break in, but practically speaking, it's nearly impossible.